subtopic of all of chemistry, because it lets us do chemistry, and lets us do stuff that makes sense. 9.2, we're going to actually start doing some stoichiometry. So what we're going to do, and we've talked about this, I'm hinting at this since probably the first day of class, is that we are going to be able to take the mass of a certain element, say 10 grams of aluminum, right, and convert that into moles. Find a molar ratio that we convert to another substance, our unknown, and then out to a mass of our unknown. So, for instance, let me clear this off just a second. I'm going to move this to the side. And say if we have this reaction right here. If we had a certain mass of this aluminum, right, so it's 10 grams of this aluminum, we can use this balanced chemical equation to predict the mass of, say, oxygen that needs to react with it. So a mass of unknown, we could say, well, how much oxygen is going to react with those 10 grams of aluminum? And we can do that because we convert aluminum into moles of aluminum. We can find the molar ratio between these two elements and convert back out to a mass. So why don't we just do this, right? Let's solve a problem where we have to actually do the conversion. So I have 10 grams of aluminum. This is chemistry, by the way. This is what we want to do. We want to know how much oxygen is going to react completely with that aluminum. Well, I have 10 grams of aluminum. Again, the first thing, just like looking at this chart up here, is I need to convert that mass into moles. We have to convert everything into moles. We can't compare things based on masses because, remember, elements have different masses. This molar mass is from the periodic table. This is the molar mass of aluminum. Notice, like we've done before, the mass is going on the bottom so that the grams will cancel out. Now, notice we're in this step. If I want to convert moles of one thing into moles of another, I need to find the molar ratio between them. In this case, I'm looking for my grams of aluminum. My molar ratio are my coefficients in front of the elements or compounds in a balanced equation. If I have a balanced equation, that balanced equation gives me the molar ratios. That tells me 4 of these react with 3 of those. So 4 moles of aluminum, and notice I'm putting that on the bottom because aluminum's on top right here, is going to react with 3 moles of oxygen. That is my molar ratio. That is the big key, because now look what it did. It converted my aluminum into oxygen. And this is one reason why we're using dimensional analysis from the beginning, is we need dimensional analysis to solve stoichiometry problems. And if you think you don't, just wait until we're doing limiting reactant problems. So we very much do. Now, our last step, I'm going to go look back up on this chart. If I have moles of an unknown, I can convert that out to a mass of an unknown using, once again, the molar mass. So the molar mass of oxygen, I want to be a little bit careful because oxygen is diatomic. So oxygen is 16, but this is O2. This is diatomic oxygen reacting. So 1 mole of O2 is approximately 32 grams of O2. Now I have my equation written down. Let's go through, make sure everything cancels out. So grams of aluminum will cancel with grams of aluminum, moles of aluminum with moles of aluminum, moles of oxygen with moles of oxygen, and I'm left with grams of oxygen. Now, we still have to do the math, but the math is the easy part. We have 10 times 1 times 3, so that's 30. 30 times 32, so we get somewhere around 900 or so. We'll divide that by 26, divide it by 4, and finally 1. And for a final answer, I get 8.89 grams of oxygen. So I know exactly how much oxygen needs to react with my aluminum. That's very good. That's good if we're running industrial processes. We know exactly how much of each of our reactants we need to make the products that we want. Now we could also solve this to find the amount of aluminum oxide that we'll make. So let's do that as well. I'm going to start again with what I know. 10 grams of aluminum. First thing I have to do with my grams of aluminum is convert it into moles. 26.98 grams of aluminum. So I solved for how much oxygen I needed. Notice this first step is going to be the same. We also have to convert into moles. Now my next step is going to be different, because now I have a new molar ratio. Now I want to find out how much aluminum oxide I'm going to produce. The molar ratio, I can erase this arrow because that's not what I'm looking at. I don't care about the oxygen now. I need to have it balanced. But what I want to care about is these 4 to these 2. That is my molar ratio. That is telling us that 4 moles of aluminum will react to produce 2 moles of aluminum oxide. And again, we're writing out units, we're writing out formulas, we're writing it all out. Now, last step, just like we did here, after we converted it into oxygen, we converted it back out to a mass. So all of these problems will be 1, 2, 3-step problems, or perhaps less if they start you off with moles. They don't have to start you with a mass. And sometimes that causes some problems for people. But as long as we have a chart, we know where we're at. Okay, aluminum oxide, if I look up its molar mass, is 101.96 grams of, and you'll wonder, where did I look that up? Well, I looked it up on the periodic table. 2 aluminums, 3 oxygens, added up, it's about 101.96. Now, before I do any mathematical operations, I need to check that my units cancel. Grams of aluminum, moles of aluminum, moles of aluminum oxide, moles of aluminum oxide. I'm left with grams of aluminum oxide, my product, which is what I wanted in the first place. So I'm going to go 10 times 1 times 2, 20, 20 times 101, divided by 26, divided by 4. And for an answer, I get 18.89 grams of aluminum oxide. Now notice a very interesting thing just happened. Let me write this down. I had 18.89 grams of aluminum oxide. That is what I produce over here. I'll erase all my messes. So 18.89 grams is what I just found out produced. Notice we started with 10 grams of aluminum. And how much oxygen again reacted with it? Let's see. 8.89. Hopefully somebody else out there sees this connection. Look at this. This is a conservation of mass. We have a balanced equation, and when we do the stoichiometry, look what we find. The mass of this plus the mass of this that we found equals the mass of the product that we're making. So we know we did it right. There's a conservation of mass. The mass isn't disappearing. It's not being created. The mass of our reactants together equals the mass of our product, and we proved it via stoichiometry. Booyah! So like I said, the other thing sometimes they'll do for us is they'll give us the amount of moles, and then they'll want a calculated amount of moles. Well, that is just going to do the mole ratio. So sometimes we'll have problems like this. We don't want to get them wrong because they're actually easier. So notice number 1 in your section review, balance the following. So we're going to balance this equation. And then, based on the amount in moles of each reactant or product given, determine the corresponding amount of moles of each of the other reactants and products. So I will just do 1. Actually, if you want to pause the podcast, see if you can do that. Otherwise, let's just keep going. Now this is a little bit trickier to balance. We might want to put a 2 here for our nitrogen. Put a 3 over here to get 6 oxygen. So there's 6 hydrogen here. There's 6 hydrogen here. But notice that gives me 3 oxygen. There's only 2 here. I'm going to have to go back and double everything. So now I'll be able to do it. I'll say there's 4 ammonia. That means I have to put a 2 here. I have to double that. 4 times 3, that's 12 hydrogen, so there needs to be a 6 here. Now I can put it through there. So we have a nice balanced chemical equation. This is why we balance chemical equations, so we can get these mole ratios. So this is asking, if I have 4 moles of ammonia, how much of everything else do I have? Well, that's kind of easy because that's just the balanced equation. If I have 4 of these, 3 of these are going to react with it. It's going to produce 2 nitrogens and 6 waters. So I'm going to skip that 1. I'm going to just do B. So if I have 4 moles of nitrogen gas produced, how much of each of my reactants did I have? Well, I can do that based on our mole ratios. So 4 moles of nitrogen are produced. How much ammonia reacted? Well, my mole ratio is 2 to 4. The 2 goes on the bottom to cancel out the nitrogen. The 4 on top is the ammonia amount. That is my molar ratio. It is 4 to 2. If I had 4 moles of nitrogen at the end, like this question is asking, how much ammonia did I start with? Well, 4 times 4 divided by 2 tells me I had 8. So most moles of nitrogen closes. We have 8 moles of ammonia. Yes? Good. Let's do one more part of it. It says we should solve for everything. So, well, how much oxygen must have reacted? Well, again, if I have 4 moles of nitrogen to start with, again, coming from this question right here, now my mole ratio is just different. 2 of these are going to be produced from 3 moles of oxygen. So I have to put on 2 moles of nitrogen again on the bottom. 3 moles of oxygen, though, can go on the top. Now, if I do my math, I have 6 moles of oxygen. So I know how much oxygen I need to produce this nitrogen. Now I could also do the same thing for the water, and I might as well. So 4 moles of nitrogen. Again, I need to look up the correct molar ratio. This time I'm looking at the nitrogen to water ratio, so I can find how much water will be produced. That is 2 to 6. So 2 moles of nitrogen to 6 moles of water. If I do the math there, I get 12 moles of water. So don't be caught up in a problem where they just give you the mole amounts. That actually makes it easier. That is one step. Most of the problems, though, that we're going to do are going to be like these original ones, where we're going to have to take that mass, turn it into moles, find the mole ratio, then turn it into a mass. So I just want to do some more problems here. So I'm going to work on, this is the section review here that you have. Question 2 says, one reaction that produces hydrogen gas can be represented by the following equation. Unbalanced equation, meaning we have to balance it. What is the mass of hydrochloric acid that's consumed? So mass, remember when they're saying mass, they're asking for grams. So what is the mass that is consumed by the reaction of 2.5 moles of magnesium? Okay, first bit, though, is we have to balance that equation. So I'm going to rewrite it and balance it. Pretty easy equation to balance. We just need a 2 in front of the hydrochloric acid. So we're looking at mass. We have to key in on those words of what we're looking for. And I'm going to write down on this side what I'm looking for. Mass of HCl. That's what I want. My given is right here, 2.5 moles of magnesium. That's what they tell me I have. 2.50 moles of magnesium. I left off the 0 just because there's laziness, essentially. Now I have moles of magnesium. I want grams of hydrochloric acid. Now if I go back and look at that chart right back here and clear it off so we can read it actually. If I start here with moles of a given, so they gave me moles. Notice I don't have to do this step. So I'm one step further down the mole train. I don't have to convert to moles if they give me moles. I should just have now a 1-2 step conversion. Find the molar ratio and then the molar mass for the unknown. So that's what I have to do. So now, again, I don't need to convert it into a mass because it's in moles. That's what I want. I want it in moles. Because if it's in moles, then I can relate between magnesium and how much hydrochloric acid will completely react with it. So 1 mole of magnesium, 2 moles of hydrochloric acid. And that's very nice, but notice what units I'd be in if I stopped here. Moles of magnesium would cancel. I'd be in moles of hydrochloric acid. Moles of hydrochloric acid, that's not what the question asks for. It asks for a mass. Mass is a gram amount. That comes from the molar mass from the periodic table. 1 mole of HCl I'm going to put on the bottom. I'm going to put the mass of HCl on top because I want it on top. I want to finish in grams. Add it up from the periodic table, 36.045 bouts grams of hydrochloric acid. Run this across, and I get a mass of 182.25 grams of hydrochloric acid. So I end up with a mass of hydrochloric acid. B, what mass of each product is produced today? So then I could do that same thing. And why don't you try these? Check them in the back of the book. Now we're starting again with 2.5 moles of magnesium. Check if you get the right masses. That's what we're doing here. We're doing chemistry. We're having fun. I just want to do one more together because this, I feel bad. I'm a bit conflicted because for such a fun problem, I hate to take it for myself, but I'm going to. It says when sodium chloride reacts with silver nitrate. Oh boy, I have to note sodium chloride and silver nitrate. This would be an awesome test question. I could visualize just writing one test question where you had to know what the formulas were from the names were from the formula, and you were given one mass of something and you had to convert into everything else. That'd be just awesome. But anyway, I'm getting too excited. So sodium chloride, NaCl. How do I know it's NaCl? Well, I know sodium's in the first column. It has +1 charge. Chlorine, halogen, -1. So it's NaCl. Reacts with silver nitrate. Silver nitrate is AgNO3. How do I know that? Ooh, that takes some memory. That takes just memorization. Nitrate is NO3. It has a -1 charge. Okay. Now it says they react. And again, silver nitrate has a -1. Silver is a +1. Those are things that we do eventually have to know, or we can't solve problems like this. Now it says when it reacts, silver chloride precipitates, and says, and notice it helps you here. It tells you what silver chloride is. So silver chloride precipitate. So we have AgCl over here. So kind of bummed that they made it that easy. But wait a second. If we want to solve a problem, we have to have a balanced equation, and this is not a balanced equation. This is saying sodium chloride reacts with silver nitrate. Sodium chloride plus silver nitrate. I wrote it out. And silver chloride precipitates, so that's our solid. But that I can't balance this equation. And you know why? They didn't tell you what else is left over. That you would have to figure out. You'd have to say, oh, look at this. I have a metal and nonmetal reacting with a metal and a polyatomic anion, nonmetal. It's a double replacement. Silver must have replaced sodium, okay? And the sodium must go to the nitrate. So I have to write that part out as well. NaNO3. And now I have a complete reaction. Now I could balance it. Notice, luckily for me, there isn't any balancing that I have to do. The equation is already balanced. Everything reacts 1 to 1. But we have to be aware of that. We have to be smart. We have to read it. So it says, what mass, if I go back to my question, what mass of AgCl? So I'm solving for grams of AgCl is produced by 75 grams of silver nitrate. So 75 grams of silver nitrate, AgNO3. Here we go. Mass all the way to mass. We want to find how much product we're going to make. First step, I can't do anything with a number until I have it in moles. So I'm going to convert a mass to moles. So here we go. That's a molar mass of silver nitrate. I looked it up. Add the things up from the periodic table. My grams of silver nitrate cancels. Now I have moles of silver nitrate. I have to look at the ratio in the balance equation. This balance equation, one of these, there's no numbers in front, so we assume it's 1, reacts to form one of these. That is my ratio. It goes in next. 1 mole silver nitrate is going to give me 1 mole of silver chloride. Good. Last step, I need to convert that out to a mass. This time I need to look up the molar mass of the product I'm looking for, silver chloride. Type that in and find it. So it is 143.32 grams of silver chloride. And my grams is going on top because I'm solving for grams. That gives 1 mole on the bottom. Run through, make sure everything cancels out. If you do, you'll find your answer, which is 63.28 grams of silver chloride. Beautiful. Highly encourage you, if you have not yet, take a look at some of these other ones. Do number 3, do number 5. I did the fun one. I'm sorry about that. I took it away from you. But try those. Check them in the back of the book. If you can't get them, we need to talk about it. Come ask me, and we can do some stoichiometry problems, because I like stoichiometry problems. So hope you had as much fun as I did. Love to do stoichiometry problems. Try them. And if you need more help, let me know. Peace be with you all. And to all, a wonderful holiday season.